Okay, in this video we're going to do a couple of examples of finding the difference quotient. So let's just recall that given a function f of x, the difference quotient is given by this f of x plus h minus f of x over h. Where by f of x plus h we mean we're plugging x plus h everywhere we see x in the formula that defines the function f of x. Okay, so for this first example I want to look at the square root of 3x plus 1. So that's my function. So I'm going to calculate my difference quotient, so I'll just write out the definition of the difference quotient first. And now I need to plug x plus h everywhere I see x here. So that's going to give me the square root of 3 times x plus h plus 1 plus the square root of 3x plus 1 all over h. Now I can simplify that just a little bit by distributing that 3 through. So that's going to give me 3x plus 3h plus 1. That's under a square root. And then I have that's plus the square root of 3x plus 1. And then all over h. And now, oh sorry, these should be minus. And now I want to simplify, and I'll simplify by multiplying by the radical conjugate of the numerator. So I'm going to multiply by 3x plus 3h plus 1. That's under a radical plus the square root of 3x plus 1. And then if I multiply in the numerator, I also have to multiply in the denominator. Otherwise, I've changed my expression. So I'll do that. 3x plus 3h plus 1 under a square root plus the square root of 3x plus 1. Okay, so that's what I'm multiplying by. And now notice in the numerator, I have an a minus b, a plus b type situation. So I know that multiplying out binomials of that form will give me something like a squared minus b squared. And that's really nice because in this case a and b are both these radical expressions, which means when I square them, the square root disappears, and that's going to give me 3x plus 3h plus 1. That's like my a squared term minus 3x plus 1. That's like my b squared term. And now this is all going to be over h times this thing that we multiplied by. So 3x plus 3h plus 1 plus the square root of 3x plus 1. Okay, good. But now notice here, this 3x is going to cancel with this 3x because we have a minus sign between them. And this 1 is going to cancel with this 1 because we have a minus sign between them. And then after that canceling, this h is going to cancel with this h, and it's really important that that happens afterwards, leaving us with only a 3 in the numerator. And then in the denominator we have this same term. So 3x plus 3h plus 1, that's under a square root, plus the square root of 3x plus 1. And that's the final answer for our difference quotient. Okay, I'm going to clean up the board and then we're going to look at one more example. Okay, so for this next example we're going to look at this rational function x over 2x plus 1. So we'll write down the definition of our difference quotient first. We have f of x plus h minus f of x all over h. So for this first term we're going to take our function, everywhere we see x we're going to plug in x plus 1. So that's going to give us x plus 1 over 2 times x plus h plus 1. Good. And then minus x over 2x plus 1. And that's all over h. So just as a reminder, this part is f of x plus h, and this part is f of x. So see, they're very similar, but in the left one, I've plugged in x plus h everywhere I saw x. Okay, good. So the next thing I want to do is find a common denominator in the numerator. So my common denominator in the numerator will be the product of these two denominators. So that means in order to build up the denominators, I need to multiply this one by 2x plus 2h plus 1, because that's what I have over here. But that means I need to do the same thing in the numerator. Good. And then over here I need to multiply by 2x plus 1. but I'll need to do that in the numerator as well. Okay, so let's see what that leaves us. So now we've got a big fraction. We're going to have 2x plus 2h plus 1 times 2x plus 1 in the denominator of the numerator. Then we have h over 1 in the denominator. And then upstairs we're going to have 2x plus 1 times x plus h. And then minus x times 2x plus 2h plus 1. Okay, so that's what we have. So let's see what we get. We're going to FOIL this out, distribute this, and that'll lead to some simplification. We're going to get 2x squared plus 2xh plus x plus h. So let's see, that is from multiplying out that term. And then from distributing this term, we're going to get minus 2x squared minus 2xh minus x. So again, that's that term. Okay? And now we have all of that is over 2x plus 2h plus 1 times 2x plus 1. And then, likewise, all of that is over h plus 1. Okay, good. Now we can simplify what's going on up here. Notice this 2x squared and this 2x squared is going to cancel. The 2xh and the 2xh are going to cancel, and the x and the x are going to cancel. And we're left with h over that. Okay, so let's write that. So this gives us h over 2x plus 2h plus 1 times 2x plus 1 over h over 1. So now if we take the reciprocal here and multiply, we'll notice that both of the h's will cancel. And that leaves us with our final answer, which is just 1 over 2x plus 2h plus 1 times 2x plus 1. Good. So let's box that. And that's our final answer. Okay, this is the end of the video.